Now this illustration deals with general requirements, and these requirements have to comply with 210.19A1A and A1B. And also, you could do the same thing using the API 500, the American Petroleum Institute standard, by reviewing sections 1.1.1 and 1.1.2. If you're happening to be designing this circuit in the oil field, refinery areas, production, or whatever. But now, notice what the note 1 says to the left of the illustration. Let's look at these notes together. All terminals are 60/75 degrees C rated. Note 2 talks about 52 amps is used based upon step 2 or method 2. Note 3 says the larger of methods 1 or 2 are used. Now, to review these methods, the overcurrent protection device and the conductors have to have enough ampacity to supply that equipment as a branch circuit. Now, some of you remember in the 2017 NEC, this same rule appeared in the 215.2A1 section for feeders, but they've added it to the branch circuits because it's applicable here. And notice what's taken place. Method 1 has a question. What size overcurrent protection device and THHN copper conductors are required for the branch circuit based upon continuous and non-continuous loads? The non-continuous load of 28 amps times 125% is 35 amp. 100% of the non-continuous load, 12 amps, is 12 amps. Add them both together, we come up with 47 amps. Now remember, Article 100 defines a continuous load as any load that could operate for 3 hours or more. So in selecting, based upon 47 amps, we go to table 310.16. We review 240.4b, which says you can raise the overcurrent device above the ampacity of the conductors. The new ampacity of the calculation is 47, so we're raising due to that calculation. So step 2, 47 amps, 50 amp overcurrent device, number 8 wire from the THHN column can be connected to that 58 amps. So a 50 amp overcurrent device using number 8 THHN copper conductors are required. And then the note says the above calculation does not include any adjustment or correction factors. Note 4 says when you apply those, a number 6 copper conductor is used, and that's been in the code since the 2014 and the 2017 NEC editions. Now let's go over to method 2. We have the same question, except now we're routing the conduit and the conductors through ambient temperatures of 106 degrees Fahrenheit. So that means we're exceeding the 10-foot and 10% rule. Now, step 1, we're applying 210.19A1 little b. We're applying table 310.15B1 as well as table 310.15C1. So what they're saying in step 1, take 100% of all the loads, whether continuous, non-continuous, demand factors, it doesn't matter. Take them at 100% according to code. So we would take the 28 amps, the 12 amps, and that would add to a total of 40. We'd go to step 2. We are selecting a number 6 THHN copper conductors We're going to our table 310.15B1 for correction factors for the routing through the higher temperature. And then we're going to table 310.15C1 because we have more, maybe say, than 3 current carrying conductors. So in the application then of the 2 tables in step 2, we take 75 amp for this conductor number 6, THHN, from the 90-degree column of table 310.16, and then we apply step 2, and we take 80%, we take 87% times 75 amp, we come up with 52 amps. 52 amps is greater than 40 amps, as you see in the calculated procedure. So solution and answer is number 6 THHN copper conductors on a 50 amp overcurrent device is permitted based upon the 52 amps per step 2 above. Now, notice that the 52 amps is large enough to supply the 40 amps, but we had to use the method 2 because the conductor produced by the calculation was greater than the calculation in method 1. So what this basically is illustrating is that feeders and branch circuits have to be sized in this manner in accordance with what is illustrated here in figure 8-15B.